Here is another example of a single sample t-test, which is a hypothesis test for a population mean when sigma is unknown. This example is an upper-tailed or right-tailed test, and this example has the raw scores or the data set rather than the summary statistics. Given below are the birth weights in kilograms of male babies born to mothers on a special vitamin supplement. At a level of significance of 0.05, test the claim that the mean birth weight for all male babies of mothers given vitamins is greater than 3.39 kilograms, which is the mean for the population of all males. That would be male babies. Based on the result, does the vitamin supplement appear to have an effect on birth weight? Assume the population of birth weights is normally distributed. Alright, so these values listed below are the birth weights, and to find our standardized test statistic, there's a couple pieces we need. We're going to need X bar, the claimed parameter from the hypotheses, the sample standard deviation, and our sample size. Okay, so here is the formula for our standardized test statistic for a t-test. And I need to set up my null and my alternative. Again, you want to set up the claim in terms of a mathematical statement using the correct parameter and structure the null and the alternative around that. So it says test the claim that the mean birth weight for all male babies of mothers given is greater than 3.39. So as a mathematical statement, that is mu greater than 3.39. No sense of inequality is implied in that problem. Because it doesn't contain the case of equality, this is the alternative. So it makes the null equal to 3.39. The null always contains the case of equality. Now this value 3.39 is the birth weight, the population birth weight for male babies. And if we are in favor of the alternative, in other words, if we find that the mean for the babies from mothers who are given the special supplement is greater than 3.39, then we could also conclude that there is an effect on birth weight. Okay, so not only is this the claim, this would be the situation where the vitamin supplement has an effect. Because if it was the same, if there was no change, then the vitamin would clearly not have an effect. So looking at our standardized test statistic, we're going to need the sample mean, the sample standard deviation, and the sample size. Because I don't have the summarized statistics, I'm going to need to get those values if I want to input into this formula. So I went ahead and inputted all of those birth weights into a list in my TI-84, and I want to get the sample mean by going to my stat menu, over to calc, and one variable statistics. This should be review for you at this point, and down arrow to calculate. And my sample mean for this problem is 3.675, and the sample standard deviation is 0.657, and the sample size is 16. So I can summarize that off to the side here. Standard deviation sample, we're working with the sample, not the population data, and n is 16. Plugging into that test statistic formula, my test statistic will be 3.675 minus 3.39, that's the claimed value, over our sample standard deviation over the square root of our sample size. To get this into the calculator, I'm going to put parentheses around the numerator expression and the denominator expression. Square root of 16 is 4. Double check that I inputted this correctly. My standardized test statistic is about 1.735. In my next video, I will show you how to get this value directly from the calculator using the single sample t-test function. It might differ slightly from this because I did some rounding here and I did some rounding here, but this should be fairly close, if not exactly the same, rounded to 3 decimal places. Now I need to find the critical value. This is an upper tail test, so I don't divide our level of significance in half. And I need my level of significance. It's given to be 0.05. Sketching the t-distribution. Shading an upper tail of rejection, indicating that it has an area of 0.05. I can go to my t-table. I will need my degrees of freedom, which is n-1. That will be 15. And if I can find my t-table, my apologies, I misplaced it. All right, so reading down to 15 degrees of freedom and over to 0.05 in that tail. Okay, again, this printing, this font is so small, it's hard for me to see. I get a critical value of 1.753. And looking at where this test statistic is placed, it is in the fail to reject region because 1.735 is actually less than 1.753. It may be a little confusing because of these numbers being permuted, but it's very close. Okay, so our test statistic, our little T star, is in the fail to reject region, but not by much. When we look at the p-value in my next video, we'll see that the p-value will be very close to 0.05. Because we are in the fail to reject region using the critical value method, the decision is to fail to reject the null. So we are not supporting the claim. And at alpha equal 0.05, there is not enough evidence to say that the vitamin supplement has an effect on birth weight.